Greeting everyone. So in this video, I'm going to be doing a physical science question from November 2024. It's based on momentum. So it was question 4. Okay, so basically for physical science, what I would usually do before even starting answering a question, I would basically try to understand the statement, which is the most important part. Because if you don't understand the statement, then you can't really solve the questions, you know. And then from the statement, you can get a lot of information, and you can get what you know, what you don't know. And the most important thing that you can get from a statement is like tips, or like hint or something like that. I'm just gonna show you what I mean when I say hint. So let's do this question. So they say of two trolleys and B, masses of 1.5 kg and 2 kg. So I can highlight their masses, respectively. And then I held in a stationary position, keyword stationary position, on a straight, horizontal, frictionless track, and then there's frictionless, with a compressed spring between them. The trolleys are released and the spring takes 10 seconds to return to its natural length. Okay, so this spring, basically what is going to happen here is that this spring is compressed between these two trolleys, and then when they release the spring, these two trolleys will start to move in opposite direction, and then this until this spring is back to its natural length. So I can write what I know. I know that the time for the spring to natural, this is the time it takes for a spring to go back to its natural length, is equal to t, right? So the time it took for the spring to go to its natural length is t, right? Okay, and then the spring then falls to the ground. Okay, we know that. Trolley A moved to the left, you can see that, and then trolley B moved to the right, and then up a frictionless inclined plane. So another keyword, frictionless inclined plane. So the inclined plane does not have friction. I will just show you in the moment why that is very important, right? Rising to a maximum vertical height of 1.5 meters as shown in the diagram below. So given this height, right? So if I'm giving something like this, I always try to write everything I know in my diagram, right? So this diagram, let me just remove these labels. Okay, I'm gonna remove this one and this one also, and then I'm gonna start afresh. So this is trolley A and trolley B. Initially they were at rest, so the velocity initial of A is 0, and then the initial velocity of this is 0, right? So we don't know the final velocity of this one, of trolley A, and you also don't know the final velocity of this one, of this is B, and then this is A, right? So we don't know the final velocity of it, right? And then what are we given? We know that this plane is frictionless, so I can even label that if I want to. So this is frictionless, frictionless, right? Okay, so what did they say about the horizontal one? So it's also frictionless. So this one is also frictionless, right? So this one is also frictionless. Yes, right. And now they say ignore the rotational effect of the wheels. Okay, that is fine. We don't have to really like acknowledge that. So what I basically did here, I interpreted everything so that I can basically get the idea of what is going on. When I said that there are hints, the hints are like as a stationary position, horizontal, frictionless, all those are like hints on many things that you're gonna see when we are doing like the questions, Okay, so yeah, basically I've understood what is happening. These trolleys are like held with the spring, and then they will just let go, and then the spring will just push these trolleys on opposite side, and then the spring is gonna go back to its normal shape. Trolley A is gonna move to the left with an unknown velocity, and trolley B is gonna move to the right with an unknown velocity, and then it's gonna go up the track and rise to 1.5 meters, right? And now let's go to 4.1. Write down the principle of conservation of mechanical energy. In physical science, basically, when they ask you to write a definition about a certain principle or law, then the chances that you're going to use it on the following question are very high. So basically, they want you to describe the principle of conservation of mechanical energy. So what this law says that the total mechanical energy of the isolated system is conserved. So we can write it down. Let me change the color. The total mechanical energy of an isolated system is conserved. Okay, so what basically it means that if we have two objects, I'm just trying to make you understand what this law says, right? So let's say we have two objects. I'm just gonna write these two objects in a box, right? And then we have this ball. Let me label this ball A, and then we have another ball B, right? And then they are moving with certain velocity, maybe, and then they are moving to the right, both of them, and then they're gonna go up on this incline, right? So at this point, we can calculate their kinetic energy, because these two are moving. Obviously they will have kinetic energy, so we can calculate the kinetic energy of this place. So we can find K mechanical. So basically the kinetic energy, the mechanical kinetic energy, the mechanical energy is the sum of kinetic energy and gravitational potential energy, right? So okay, I think I made a mistake here. It's just the kinetic energy here, of both my objects. So it's kinetic AB. Obviously, since the height is 0 here, then the potential energy is 0, right? And then as we move along this plane, these two objects are gonna gain this is object A and B, and they are gonna gain gravitational potential energy, right? Because remember that gravitational potential energy, which is U, is equal to mgh. So as the object is moving because remember, we cannot really create or destroy energy, but we can convert energy, right? So now the problem is that as these objects are moving, they have kinetic energy, and then as they're gonna move along this track, they're gonna slow down, right, until they come to rest. Now the question is that all that kinetic energy, where did it go? Because we know that it can never be lost, or it cannot be created. So basically, as they are moving along this thing, they are gaining potential energy, but they are losing kinetic energy. So it's the changing of things. So as they're moving here, that kinetic energy that they had at this point is gonna be converted into gravitational potential energy. Hence, that is why we're saying they are gaining gravitational potential energy. Remember that as you move like vertically, like this. As your height increases, your gravitational potential energy is also increasing, right? So what I mean about that is that an object with a height of 0 has 0 gravitational potential energy. But if an object is very, very, very high, like let's say we are on the moon, and then we're gonna drop something, not on the moon, like let's say we're on the very highest level of the air, like maybe where the aeroplane goes or something, and then we drop a ball at that point. If we drop the ball at that point, when it hits the ground, it's gonna hit the ground with a large amount of energy, like a very, very large amount of energy, right? Because as the ball was very, very, it has a very, very high potential energy, and as it moved down, it's lost that potential energy to kinetic energy, right? Remember, kinetic energy is equal to 1 over 2 mv squared, right? So as this thing is gaining kinetic energy, it is moving down, its velocity is also increasing, right? So the kinetic energy is increasing, the velocity is increasing, so it will hit the ground with a large amount of energy. Hence, when it hits the ground, it's going to dissipate a lot of energy, so it's going to be a disaster, right? Unlike an object which is thrown like at a lower height, then the energy will have a lower potential energy. So when that object is dropped down, that smaller potential energy is going to be converted into kinetic energy, right? Because it's going to move now, right? So it's not going to make a lot of damage, unlike an object which have a very, very high height, right? So I wanted to explain those two things. So what this law basically says, right? It says that at point, this one, and this point, it said that the sum of the kinetic energy at this point is the same as the sum of the kinetic energy and potential energy at this point, because energy can never be lost. If the kinetic energy is decreasing, the potential energy must increase, right? So that the energy is conserved. So that's what this law basically says. So in physics, if you understand the law, you can solve a lot of problems, because we learned law in order to solve problems. So we have a problem in this one. This is a problem, right? We're gonna use this thing to solve that problem. So basically, to sum up all these things, the formula for this law is basically say that the sum of mechanical energy initial is equal to the sum of mechanical energy final, right? Meaning that kinetic energy initial plus U initial is equal to K final plus U final, right? Yeah, these are the same thing. This is what basically this law says. As long as it is an isolated system, keyword isolated system, right? What isolated system means is that the net external effect is 0. So we can ignore all the external effects of this thing, like air resistance, all those things. Like we can really like neglect them, or they're absent, like for example, if there was friction, then this law will not really apply, because friction now is a non-consecutive force, but we're going to learn about those in future videos. So friction is like a non-consecutive force, meaning that it does not conserve energy. It actually kind of dissipates in it, but you're going to learn about those in the future lesson. So if you have like friction, air resistance, all those stuff which does not conserve energy, which basically dissipates energy. I don't want to say they do not conserve energy, but they dissipate energy. Then that is no longer an isolated system, because there is a friction. Now the next external effect is not 0. So the friction with the ground is now affecting our system. But if we just have these two objects, and then there is no like force, like there is no non-consecutive force acting on them, and stuff, like there is no friction, there is no air resistance, then that system is isolated. But most in metric, you will deal with friction as like the thing that is causing your system not to be an isolated system. Once they say friction is there, then that system is no longer an isolated system. So that's what they mean about an isolated system, is when the net external force, when the net external force is equal to 0. So if you sum up all the external force, they're equal to 0, meaning that they have no effect on your system. In this case, your system is this object and this object, right? This is your system plus this tracks, right? But then if you add friction, then the net external force is not going to be 0 now, because the friction, there is a force, so the net force is no longer 0. Once there is friction, then the net force is no longer 0. But in absence of friction, our system is isolated, right? Okay, let me just remove this thingies. I hope you understood that. So that is what basically our law says. We're gonna apply this law in this problem, right, to solve this problem. That is what beautiful of physics. You learn about a law, you understand the law, then you apply it, right? So now they say calculate the speed of trolley B at the bottom of the incline. So they want the speed of this trolley here, right? Let me label this as point A, right? So because we have an isolated system, we can use the law of conservation of mechanical energy, right? We can use the law of conservation of the law of mechanical sorry about that, the principle of conservation of mechanical energy. They say that let me label this as point A, right? Then the top one as point B. So as the object moving from point A to point B, I said that it's gonna gain what? I said that it's gonna gain gravitational energy, and it's gonna lose kinetic energy. Hence, that is why it's gonna slow down, right? Okay, so at this point, there's a higher potential energy and zero kinetic energy, and at this point, there's a higher kinetic energy and there is zero potential energy. Okay, so they want to calculate. They say calculate the speed of a trolley B at the bottom of the incline. So we're gonna work. Okay, let's look at our statement. I did not really specify whether the trolley was at rest at point B, right? But I was just gonna assume that the trolley moved along the incline and then just stopped at that point B, right? So then we're gonna apply our law. We said that the sum of mechanical energy initial is equal to the sum of the mechanical energy after, right? So this is Ki plus Ui is equal to K final plus U final. K, we know that it's 1/2 mv squared, and this is obviously initial, plus this is mgh initial is equal to 1/2 mv squared final plus mgh final, right? But you know that at point A, since the height is 0, that means that our potential energy is 0, right? So we can say this is just simply equal to 0. So we can erase this. This is just 0. So plus 0. And then we know that at point B, assuming that the trolley was at rest, then we know that the kinetic energy is going to be 0, right? So at point B, the kinetic energy is going to be 0. So we're left with this formula, 1/2 mv squared is equal to mgh, right? So we know the mass of the trolley, 1/2. What is the mass of trolley B? We are given that it's 2 kg. So we're going to have 2. And then we want its velocity, which is initial velocity squared. We know its mass, which is 2, but I could have just divided by m both sides. And then g is 9.8. The final height is equals to 1.5. Is it 1.5, right? Yeah, it's 1.5. And then we get our initial velocity as I don't know if anyone has a calculator. Okay, so we can divide by, so this is going to be vi squared equals to all of this, therefore v initial is equals to, let me get a calculator, sorry about that, very sorry about that, sorry, give me a few minutes. I'm just looking for my calculator. Okay, so yeah, basically that is it. This is how you really approach a physics question. You just first interpret, and then you write down what you know and what you don't know, and then after that you can then solve the question, right? So that is what you basically do with physical sciences. Yeah, sorry, let me just get this. Okay, I'm almost there in 1.5. So I get v squared is 29.4. Therefore, adding the square root on that, where's the square root? I can't really find the square root. Sorry about that. Maybe you can just give me the answer. Okay, now that's the square root of 29.4, 29.4, right? Which is, so it's the square root of, I'm having problems here, square root of 29.4. yeah, so I get the answer of 5.42 meters per second. Yeah, so that is our first answer. Yeah, and then I'm gonna do the following questions on the next video. Next time I'm gonna try to make my video very, very short, because this one was very, very long for one question. So yeah, I'm just gonna try to compress everything out. Yeah, see you on the next video. This was just an introduction to my channel, really. Like, yeah.